Tutorial I will show you a Simulink model for MPPT and boost converter in a PV system, basically PVI, okay, using specialized power system. For that I'm browsing my library and under Simscape electrical and a specialized power system, okay, and under sources you will find PVI here, okay, and I'm taking power GY block here, okay, and I will need series RLC branch, okay, this is series RLC branch, and under sensor and measurement voltage measurement block, okay, and now in the input of irradiances I am considering a constant, okay, and I'm setting initial value of as 1000, okay, and in the next time I'll vary this value as irradiance value varied over time, okay, and I'm taking another constant block for temperature and setting value like 25, and in PV array we need some information, okay, okay, like specific irradiances I want parallel string as 2 and series as 10, okay, and you can see here open circuit voltage and short circuit current is given here, and if I set irradiances like 1000 and 800 and 500, okay, in this irradiances we'll see our maximum power point, okay, and if I click on plot you will see the maximum power point, okay, and in case of the 100 irradiances you can see the power is 213, it's not accepted. You have to first click on OK and then click on it, PV array, and plot this. Sorry, one module, so you have to take array, okay. Now click on this and you can see here the maximum power at 100 irradiance is about 4263, okay, and I'm taking as 100 irradiances power is 4263, okay, and I need 100 irradiances power and 500 irradiances and power, okay, and here you can see here at 800 you can see the power is about 3435, okay, so the power is 3435, and at the lowest value like 500 I can see the power is about 2159, okay, the power is 2159, okay. So this value will be used in later part of this video, okay. I'm clicking on this, okay, and closing this, okay, and for measuring the output we need bus selector block. I'm taking as bus selector block here, and double clicking on the bus selector block, and I'm deleting this signal 1 and signal 2, and I want voltage of the PV array and current of the PV array, okay. Now click OK, and we need scope, okay, and scope I need scope under sync, and this is our scope, and this is our voltage, and this is our current, okay, and I want to calculate the power here before the MPPT. Here for that we need a product block. Double click on the canvas and search for product, and you will find it here. So the product is the voltage and the current multiplication, and here I am taking another scope block. Okay, and I need from and go to block, which will make our system more clear. Okay, from, and this is go to block. Okay, and I'm taking power from this signal and assigning as P. Okay, click OK, and I will need the voltage also. This first signal is our voltage. Okay, so I'm setting and this is signal V. Okay, and yep, I'm setting a tag as V. Click OK. Okay, now we have to set our PVI. Okay, I'm taking RC branch here, and resistance smaller value like 1 E minus 3, and capacitance 270 E minus 6. Okay, click OK, and I'm rotating this using Control R. I'm connecting this here. Okay, and this will be connected here. Okay, and then I will need a RL branch before the boost converter. Okay, and I'm setting as RL branch, and inductance like 560 E minus 6. Okay, I'm connecting it here, and then I need a boost converter block. Okay, uh, boost converter is under Simscape, then electrical specialized power system, and under power electronics you will find boost converter block here. Okay, I'm closing this. Okay, okay, yeah, this is our input here. Okay, and I need a reference. Okay, which is under utilities, and this is a ground block. I'm setting it here. Okay, that's okay. Boost converter, it's okay. And now the gate signal will be PWM generator. Okay, and PWM generator block under power electronics and power control. You will find PWM generator block 2 level. Okay, and I'm connecting this here, and this is will be for single phase full base 4 pulses. Okay, and frequency is I think okay, and I'm taking this 3000. Okay, now click OK, and this is our get pulse, which will be output from our MPPT. Okay, I'm setting as duty, sorry, D get. Okay, and click OK, and boost converter here I'm taking count here, and we will need another LC block. Okay, basically we will need another LC block here at the output terminal of the boost converter. Okay, okay, and I'm setting as the capacitor value will be larger. Okay, and this about half of E minus 6. Okay, click OK, and then I need a resistive branch as a load. Okay, and its value I'm taking initially 30. Okay, and the value will be changed when irradiances I will change here. Now per minute I'm taking as 10, and sorry 30, and connect it here. Okay, now this is our voltage measurement block. This will be connected here, and scope. Okay, sorry, I'm dragging this code here. Okay. Okay, our circuit part is okay. Now we have to add our MPPT algorithm here. Okay, and I have already shown a video on MPPT using state flow as well as the MATLAB function. Okay, let's check this video. I'm not explaining this MPPT algorithm here. You have to check this video first. I will give the video link in the description. And this is my MPPT function. I have previously shown on my video, and I'm copying this MPPT, and this is my I'm pasting this block here. Okay. Okay. So VPV basically is our voltage signal from the PV array. Okay, this is V. Okay, this is V, and I'm connecting this VPV here, and VPVs will be delay of the VPV. Okay, for that I will need under discrete and init delay block here. Okay, and this is V previous block. As I have used a discrete block, so our simulation type will be discrete. Click OK, and VPV is the PV power. Okay, I'm dragging this here and set it as P. Okay, and PPVS will be our delay version of the PPV. Okay, and DT will be the delay version of the output D. Okay, I'm connecting it here, and I need a goto block again. So this gate will be connected to be here, so I'm copying this and paste it here. Okay, now I think our circuit is okay. Here our irradiances is 1000. Okay, and temperature 25, and I have set a load as 30, and this is our MPPT algorithm. When irradiances is 1000, our maximum power should 4263. Okay, and I'm taking a display block so that we can easily understand this. So this is our display block which will show power. Okay. Okay, now run this model. Sorry, I have used PWM generator level 2. It would be DC-DC PWM generator. Okay, and you will find it under power electronics control and PWM generator DC-DC. Okay, and this is not suitable here. This is used for inverter. Okay, now it's okay I think, and run this model. Now I can see our power is increasing. 3006. Okay, I can see our we are getting a constant power here. Okay, but we are not getting our maximum power. Okay, so this is because of our load mismatch. Okay, I'm explaining it here. At irradiances 1000, our maximum power should 4200. Okay, but we are getting less value because we have used a larger load, because larger load means low resistance. That means the boost converter will consume a larger current. Okay, for that we have to increase this resistance value so that the boost converter cannot take much power, okay, mass current. For that reason, if I increase this resistance, that means reduce this load much lower as compare the previous, then the PV voltage can increase larger, okay, and it will reach the maximum power point. Now run this model. You can see the power wave from here. You can see our PV array is working about a maximum power, okay. This is about 4 to 4 to 414 to 75, which is our maximum power, okay. Now the irradiance value is not constant values, okay. It changing time by time, okay. Now for that I will consider it as sources and signal generator. I'm taking a star generator here, okay, and under passive I will take a variable register, okay, uh, and I'm removing this IR here and connecting the star generator block here, and time like 0 1 2 3 4 5, okay, and amplitude will be like at 0 second it will be like 1000, then 1000, then I am choosing at 800, and again 800, 500 and 500, okay. And if you see, sorry, we have to add our bracket here, and I'm connecting irradiance value here, and I'm adding a scope to visualize this, okay, and I'm taking it here like tag value like IR, okay. Now click OK, and for resistance value I'm removing this load, and I'm setting this resistance value, okay. Because we cannot use to much larger load at the lower irradiance value, okay, and it will not works at maximum power point. For that I am taking variable register block here, and I'm taking star generator block again here, and this is for resistance, okay, and I'm choosing a 40, then 40, it will be 50 for 800 irradiances, and at lower irradiances or resistance value have to mass too larger, okay, because of its a lower power output, okay, and click OK, and I'm taking it here, and I'm taking like RES resistance, okay, and take the bottom block here and RES. So this is connected to our variable register block here, okay, and if we take a scope, this is our power output, okay, power, and another from block, okay, this is will be IR, click OK, and I'm setting at IR for the comparison, okay. Now our model is okay. Now run this model, okay. Now you can see it's working at 1000 irradiances. This is theta 3034 means 800, and this is, I think it's got some garbage value here. View layout, and this is 2. I'm running this model again. This is our power output. Okay, as you can see here, uh, at first 1000 irradiances its value was 4200. Okay, and after that its value 334. Sometimes the PV array gives 0 output. Okay, for that reason we are not getting our actual value here. Okay, um, if I remove this, okay, oh sorry, here I have mistakenly 3 4 5. Okay, I mistakenly added 5000. Okay, it's much larger value. We have to set it as 500. Okay, now click OK and run this model. It should work fine. Let's see what happens. I think it's okay. Yeah, now let's check the scope. Here you can see our irradiances value is firstly 1000, and our power is containing a steady state value like 4200. Okay, and you can see here using the measurement block here, and when its value fall to 800 irradiance value, you can see the maximum power is reduced to about 3400. Okay, which was our required value. You can see 3400, and when our irradiance value is 500. Okay, and you can see the power is about above 2000. Okay, which can be considered as 2100. Okay, so this is the way you can model your PV array to get the maximum power point. Okay, using the uh, MPPT algorithm. Okay, so this is all for today. Thanks for watching. In the next video I will show you how to add PV array to the grid. Okay, so again, thanks for watching. See you in the next video.